technology, AMD Pacifica technology, virtualization technology, while Vitriol uses Intel VTX technology. This is not going to be a lecture about BluePill. I gave several lectures about BluePill already, so I'm not going to go into details of how it works. Basically, it works in the way that it runs on the native system. It creates a hardware virtual machine. It moves the running operating system into the hardware virtual machine, and itself, it becomes a hypervisor. This all happens on the fly. It takes like less than 1 millisecond to do all of this. And the native operating system, which is now guest operating system, doesn't even realize that it has just been moved into the virtual machine. Second, how is what? Yeah, this is what I discussed many times during my BluePill talk. The performance impact as an experience for the user is 0. There are some instructions which are intentionally intercepted by hypervisor, like read MSR instruction, which presents some impact which could be used for time-based detection of BluePill. But there are several problems with it in practice. One problem is that we need a trusted time source. The other problem is that we almost done this actually on a generic way of cheating timing analysis without cheating timers. Right? So basically the effective performance impact is 0 because this is hardware virtualization. Second? I'm sorry, we're going to discuss it later with the microphone in the audience, okay? So timing analysis is one theoretical way to detect it. As I said, it's not practical, and as I said, we have almost completed an improvement for BluePill which allows to resist timing analysis. Detecting side effects. We could look at network communication. Again, this could be very challenging if this type 3 malware uses some kind of advanced cover channel, like Nushu, for example. And also we can look at disk usage, or we can analyze PCI-ROM or BIOS in case it was implemented as persistent memory. But actually then it wouldn't be type 3 malware, then it would be type 1 malware. So in ideal case, when it's actually a non-persistent malware, well, the disk usage, analyzing disk usage doesn't help much. So I don't know any feasible way to detect type 3 malware today in practice. We might imagine that the particular implementation of virtualization, I don't know, Pacifica SVM revision 1.2, for example, contains some implementation bugs which could allow for creating a detector to detect the presence of a hypervisor. Most likely they do have such bugs. So we could think of some kind of red pills for Pacifica, for VTX. But this is far from being a systematic way of verification, right? This is just a hack. They might just fix the problem and it wouldn't work on future processors. And we need a systematic way. So the only way I think it could be used systematically against BluePill would be a hardware-based well, basically it would be introducing a new instruction to SVM or to VTX. Well, let's say it's SVM check. Let's say it's SVM check. And of course, this instruction doesn't exist today. But let's say we need this instruction to detect hypervisors in a generic way. This instruction would work like this. We it would require some password, which would be processor specific, model specific, and then it returns 0 or 1 depending on whether it's executed inside hypervisor or on in a native mode. Password should be different for every processor, so every user gets a password and a certificate when gets a new processor. Or it's displayed in BIOS post screen when computer boots. This is to prevent creating generic programs which behave differently on inside virtual machine and outside virtual machine. Because for sometimes we might. Why is this important? Sometimes it's important. It's mostly important for antivirus industry, I would say, because they want to analyze malware inside virtual machine, and not lots of, but some malware today, for example, they try to actively detect the presence of, well, not hardware hypervisors, but software hypervisors like VMware. So they try actively detect it and then to behave differently inside VM and outside VM, right? So actually, this is not that. This is quite logical that we might want to prevent this to happen. And this password could be entered to the antivirus program during installation, then could be used only by this program to detect whether we are blue-pilled or not. A few words about kernel protection versus hypervisor protection. Because what we can do today, actually, we can only do hypervisor protection. So we can create something similar to Bluepill, load it into kernel and load it into the system so that it will block all the other hypervisors from loading. This is actually not that easy as it sounds. Actually, it's easier to create Bluepill rather than anti-Bluepill hypervisor for several reasons, DMA access being one of them. But this is feasible, in my opinion. In contrast to kernel protection, which we can never guarantee 100% because kernel is huge. And also we have all those third-party kernel drivers, which could contain buffer overflows. This doesn't apply to hypervisor. We can have very little cut in hypervisor. So this is feasible, but so far nobody has created such a product as far as I know. Okay, so the bottom line is, Type 0 malware is beyond the scope of my research because it's not something which compromises systems. Type 1 malware is relatively easy to fight today. Type 2 malware is a challenge, and we cannot solve this type 2 malware problem without the help of operating system vendors. Implementation-specific attacks are always possible against software-based detectors, but we can mitigate those attacks in practice by using hardware-based detector or hypervisor-based detector or custom private detector. Systematic verification against Type 3 malware seems to be unfeasible today and seems to be feasible only if CPU vendors introduce special instruction like this SVM check, which I just showed. Prevention against Type 3 malware seems feasible, but as we know, prevention is never enough. When reading eWeek a few days ago, I found the 10 key predictions for 2007, and prediction number 5 was that by the end of 2007, 70% of enterprises will be infected with undetected, financially motivated, targeted malware that evaded their traditional perimeter and has defenses. So, can the good guys win? Now without the help of us vendors. And who can we trust? For sure not our operating systems. Some credits and questions.
Okay, we will take a few more minutes for question and answers. We have the first question here at the microphone. Please come here and queue if you want to ask a question, as we only have one microphone at the moment. Thank you.
Yeah. Hardware-based memory reading looks promising, but you have two problems even if you disable paging on the machine.
Okay.
As far memory reading does help nothing if you don't have the state of the MMU table, and the MMU table is cached in the processor.
Well,
so you want.
I don't really need to have because the state of this table is just physical to virtual mapping. I don't really need that as far as I can make sure that all executable pages are okay. As far as I can find out whether the page is executable, and second, whether I can verify the code on it. But as I just was talking about this, I found out that I realized that you might be right that I might not be able to find out whether the particular page is executable or not without reading this. Yeah,
Yes.
that's a good point.
And you didn't see the true state in memory. The true state you have only in CPU. And if you cannot take a hardware look at the CPU,
What do you mean true state?
The true state of the MMU state of the MMU translation table. It's cached
No,
in.
the only thing I need actually is to find out the attributes of a given physical page, whether
Only
it's executable or not, and its contents. This is all I need. But as you pointed out, I might not be able to find out whether it's executable or not by just using DMA access. That might
Yes.
be true,
And
because I might. No, but on the other hand.
They might the translation table may change in the CPU and is not written back to memory. So you have the CPU sees another mapping of memory as your DMR device.
Okay, yeah.
You have to
I agree.
interpret.
Yeah.
You have to interpret.
That's a good point. Without but I don't care about mapping. I just care about attributes of pages.
Okay, that's one point. And another point is next generation CPUs got an I/O MMU.
I know that. Yeah.
And so you what is calling?
Yeah,
you can hide
remap.
physical memory from DMR devices.
IOMMU is a different thing. Yeah, I know that.
Also,
Yeah, but
it
it's a good
doesn't
point.
help. It doesn't help so much.
Yeah, and also as I just noticed, we can cheat hardware-based memory access also in some different ways.
You need help from the CPU. More help.
Yeah. Okay, thank you very much. That was very good. Any more questions? No.
Yes, there are questions.
Sure.
One question is regarding the hypervisor. I'm not sure if the newest CPUs even have the JTAG feature. Normally, every CPU has a JTAG interface to do some debugging stuff. So it would be possible to hook the JTAG to some magic hardware on the computer, so I can read the registers via JTAG, so I know
You want to read what?
the registers.
The registers of CPU.
Yes, and so I can-
via JTAG interface.
Yes. So I can. Yes, but that's not a problem. So I hold I hold the computer, read the JTAG thing, and then I know what is going on or not.
Well, this would be great, but I'm not sure if it's possible. I mean, do you know? I mean,
Depends on the CPUs.
Yes, but if, for example, I know it from the PowerPC, it's possible to read them at a speed of maybe.
is it?
Huh? PowerPC.
Yeah.
Yes, it's possible to read via JTAG, and I think it's had 30 megahertz or something. But so you can read some registers, and you have to hold the CPU just for a small time.
Okay, that's interesting. That's very interesting.
But so I think these debuggers also. I know if the Pentium 3 has such JTAG debugging feature. I'm not sure if modern CPUs have it. You have to read the data sheets. Mostly they are under NDA, so you have to wait until you get the data sheets. Another thing regarding the.
But so this PowerPC does it use hypertransport? Or how is it connected?
JTAG is a standard that has some pins, and you can say
it's a PCI standard, right?
no. JTAG is the JTAG standard. It has some pins.